So thank you. So as Deepak said, hashtag ODSC, we're from Data Kitchen. Madan is from Celgene, so we're happy to be here. If you want a copy of the slides, they're eventually going to be posted by the ODSC, or you could just send me an email, gil@datakitchen.io, not .com, .io. So what's this talk about, right? So it's a case study, it's pharma, but the takeaway, we think of it as like in one slide, it's like how do you make lots of changes, right? So dozens of changes. We'll be talking about a data warehouse. We'll be talking about data visualizations, also a little bit about models, without breaking things, right? It's easy to make changes, but how can you do it with high quality and using the tools that you love? So that's it in one slide. And what I like to do is just have this in the back of your mind. This is a nice 3-day conference. There'll be a weekend. But what can you do on Monday when you get back to the office? What are the tidbits I could take and actually try and do it Monday? So remember that. So what's the agenda? We kind of have a 3-part, just 3 sections. Introduction to us, and we talk about the analytic landscape. Then we're going to talk about data ops. And then finally, we're going to go into some detail on our case study, which is a pharmaceutical launch. So the speakers here, Madan, we work with him. He's a senior manager at Celgene, and he, in his role, he turns data into strategic and tactical insights for sales and marketing teams. And Chris and I, we're owners of a company, Data Kitchen. We have a booth out there. And our backgrounds are similar, where Chris did a lot more algorithm work than I did, but we both started in software development and work with data. And I have 2 slides just introducing each company. So at Data Kitchen, we're a software company focused on data ops. We'll be spending a lot of time talking about what is data ops, and what it does is it lets people deliver fast with high quality using tools they love. And how did we get into this? Well, Chris and I worked together at a different company, and so a little story as background. And our CEO was a Harvard-educated medical doctor, very smart, very driven, very demanding. Chris was the chief operating officer. I was VP of engineering, and we encountered these 3 patterns. One of them is moving quickly. So there'd be a request for a feature. We'd go figure it out. We say, oh, this is it. We've got it. It'll take 2 months. And the reaction we'd get from our CEO was, what, 2 months? I could do that over the weekend in Excel. I was like, oh boy. So we're moving too slowly. So we had to figure out how can we move faster. And then there's times we'd move fast, and we get a call from our customer. The data's wrong, right? We were an analytics company. We produced data sets for pharmaceutical sales and marketing groups. And we produce, and we get a call on Friday, the data's wrong, I need it fixed. And we wanted to find some way where we didn't have to worry and we could enjoy our Saturday mornings with our kids at our kids' soccer games and not have to worry about data issues. And then there was the third thing, which is people wanted to use the tools they love. Some people just used Tableau. They loved it. They were efficient. And if they were told they had to use something else, they weren't happy and they were less efficient. So this is a common theme, and out of that came data ops. Now Celgene, they're committed to improving the lives of patients worldwide. That's pretty awesome. And it's in the treatment of a couple really serious ailments, cancer and immune and inflammatory conditions. And that's the world that Madan works in. So that's our introduction. And what I'd like to do next is talk about the analytic landscape. And I'm actually going to start with a quote from Madan's boss. He said, "I'm competing with Amazon." And when he said this, I thought to myself, what? You're the director of analytics. I thought to myself, are you selling things from your garage? What do you mean you're competing with Amazon? So I said, what do you mean? He says, well, when my bosses and my customers want something and they make a request from me, they are expecting something like Amazon. In Amazon, you make a request, you get it in 2 days, you could get it overnight, and that set an expectation. So, Amazon Prime came in 2005, and that's the beginning of very high expectations. And just think about it. What else has Amazon done? Remember, in the old days, what did it take to get a server and get it installed? Right? You had to buy it, it had to show up, it had to be racked. Now, with Amazon and Amazon Web Services, you just push a button, launch instance, fill out a form, boom, you have a server. And guess what? These expectations, it's just becoming more so, right? Amazon's experimenting with drones to deliver things even faster than overnight. So what I want to do is in the next 2 slides talk about expectations as part of the analytic landscape. So the first comes from the software development world. And if I think back in the timeline since the 80s, the rate of delivery is getting smaller and smaller, right? And the methodologies and it's been driven by these methodologies. So first there was waterfall, delivering every 6 months to a year. That was pretty good. Then came iterative development, things improve. Then agile, maybe you're on the scale of a month or a week. And then came DevOps frequency. And actually this slide is old. It says today companies could deliver every 11 seconds. This is actually, again, Amazon. They update their website almost 2 times a second right now. So that's one thing driving customers' expectation, is that whatever's out there is going to evolve and get better and better. All right, the next, this time frame's a little bit longer, but it's from manufacturing. And the time frames are, early on things were handmade, so that's the artisanal phase from, as Tom Davenport might call it. Then came mass production, and then now we have lean manufacturing, and there, what I want to highlight is the focus on not doing things that don't benefit the customer, and also statistical process control of the entire production pipeline. And what's the result is that things, not only from the last slide, are coming faster, that the quality is very, very high. So things are moving fast, and the quality is getting better. So that's what our customers think. Now, what's another backdrop in analytics? And that's the technologies. This just shows Hadoop over time. And I really like this slide from Datanami because it shows there were just a few technologies / projects in the beginning, and it's really exploded, and it continues to do so. And each of these has some advantage. And this conference is full of really great tools and techniques. So, it's key to take advantage of it. And there's a similar trend with Amazon, where 10 years ago there were just 2 services, EC2 and S3, and now there's 70. So again, there's so much more available. You want to be able to take advantage of things as they come to you. So now there's this one other aspect here, is once something's delivered, how long are you a hero? How long are people happy? So this is a graph of radioactive decay. And you can think about it is when you deliver something, either a model or a prediction or a scoring algorithm or even a dashboard, people are pretty happy. It's like, oh, good, I could use this. But then after time, it's a little bit less so, and then at some point, it's as if you haven't done anything all. So with analytics, there's always more that has to be delivered so people can, you have to earn your keep every day. So finally, with all these challenges, Gartner says that, assesses that around 50% of analytic projects fail. They're either late or don't meet objectives. And you might hear some of these sayings at the water cooler. Why does it take so long to do something? Why can't we get something out of the door? Your group is too slow. So what's the answer? How do you deliver on these high expectations of speed and quality? And to us, the answer is data ops. And I'll just explain what data ops is and then turn it over to Chris. So we think of data ops as the combination of three things. One is an agile mindset. So not any particular methodology, but the mindset of deliver frequently and get feedback. Then there's DevOps, which feeds in, and we see that as a technical environment. How can you deliver frequently and with high quality? You need a technical environment to support that, and that's what the middle part of our talk is about. And finally, from lean manufacturing, the process control. As data moves through your process, your pipeline, you want to make sure quality is high, garbage in, garbage out. You want to be alerted if something's fishy. You don't want to get the phone call from your customer, hey, what's wrong? And you say, I don't know. You want to actually say, we've noticed something in the data. Let's put that in a release note and alert people to what's going on. So that's how we see the world of analytics today. And now we're going to talk about data ops.
Hi, everybody. Can people hear me? Hi, everybody. So I'm Chris Berg. Also work at Data Kitchen. So I'm going to do two things. One is I'm going to try to put a mental picture in your head that this concept of data ops exists in. And then second, we're going to talk about 7 principles to do data ops. And so we're about 10 slides or 15 slides that go through that. So the first picture that I want to put in your head is that analytics is really a team sport. How many people here call themselves a data scientist? How many people have done or call themselves a data engineer? So, and then how many people sort of work with Tableau and do visualizations? Modern, you have to raise your hand. So there's a lot of different roles. And in the beginning, there's, I've been in the analytics field for a while, and you kind of look for this unicorn type person who could do everything, right? They could talk to the CEO, they could manage charts, they could do models, they could do data. And perhaps some of you are that unicorn, but they're very rare. And when companies get bigger, they want to have analytics as a core competence. They want to be a data-driven organization. And to do that, it's a team sport. There's lots of players there. And so to do that, you have different people like data analysts, data scientists, et cetera. And they work in a certain way. And how many of you people know or have heard of agile development or agile software? Okay. And so that's a way to organize a team of people. And for us, you can go to a bookstore and there's racks of books on how to do agile. And we're not going to talk too much about how to organize a team. Because while very important, there's lots of other people who can do that. The main idea of this slide is try to satisfy your customer. Focus on delivering value frequently. And so there's 4 values, 12 principles, and that's really our focus is being pragmatic and not dogmatic. And so, like I said, data ops, it's a team sport. There's lots of roles and lots of people involved. And from my perspective, a lot of the business customer on the right, that group of people, the analytic customer, are very unhappy with the analytic team. I see that people who go up in front of, after working a week or 2 delivering an analysis or a model, kind of walking out of a meeting with their shoulders down. And it's really frustrating because it's not because they have done something wrong or delivered something in error. It's because they are asked to do more. They're asked several follow-up questions. They're asked to put something in production. And that seems really backwards to me, that if you do a good job and someone asks for more, you shouldn't be frustrated. You should be able to do that and deliver fast. And then second, there's lots of tools. So if you walk down that hallway, there's all sorts of people hawking different tools to transform data, to model data, to visualize data. There's there's all those tools have pluses and minuses. And there's a great trend now to do self-service, to have, instead of having one tool, have lots of different tools. And where you fall on a sort of Grand Inquisitor, Brothers Karamazov, have everyone has to focus on one tool or have a diversity of tools. Nonetheless, there's just a lot of tools out there today. And from our perspective, those tools create code. And when we use the word code from a software standpoint, that's got a lot of meaning to software engineers. I work in code. I work in team in a code. And I think that meaning for them comes from complexity. because code is very complicated, and in some cases, a software team can create, metaphorically, a big hairball of complexity. And if you don't manage that in a certain way, it can slow the team down. And so whether it's you're writing a script or doing a predictive model or writing some SQL, even in Tableau, you're creating Tableau functions. The latest version of Tableau has got able to run Python. At the end of the day, yeah, it's some configuration, but it's code, and that code creates complexity. And so what software development did with DevOps, we're trying to do with data ops for that code. And then finally, we see analytics as a manufacturing process. So on one side, data goes in, and the far end value goes out. And along the way, data is transformed, models are added, charts are added. But think of it like Toyota in a manufacturing line. Day in and day out, whether you're doing things in batch, whether you're doing things in real time, you're creating value for your business customers. Think of that as a process. And how should you monitor that process? How should you improve that process? That journey as things go along from one end to the other. And it's got to be repeatable and improvable. So this picture is kind of our view of the world with data ops. So there's lots of tools, there's lots of people, there's code in the middle, and there's a manufacturing-like process that you have to manage. That's sort of our philosophy or perspective on the analytics world. It may not match what you hear. Other people say, just put all your stuff in our tool and things will be great. We just think that this is the reality of the world. So what I'm going to do now is talk about 7 steps, 7 kind of best practice steps that you can do yourself. And actually, we're going to do something interesting at the end of this. We're going to ask you to talk to your neighbor. And I know you go to conferences, and we're all introverts and don't like talking to people, but often we've given this talk enough that if you talk to your neighbor and then come up and tell other people what you said, you actually give a huge amount of value to the people in the conference. So we're going to have a 5-minute exercise where you talk to your neighbor, answer a question, and then come up to those brave enough to come up and give their answer it would really be appreciated. So the 7 steps to data ops. So we're going to talk through these. So the first one is add data and logic test. The second one is use a version control system. The third one is branch and merge. The fourth is use multiple environments. The fifth is reuse and containerize. The sixth is parameterize your processing. And the seventh is orchestrate 2 journeys. So I've got slides that talk about this. So add data and logic tests. So I got gray hair. I've managed software teams. And I would never, ever push out software that wasn't tested and wasn't tested automatically. It makes the hair stand up on my neck to think about having software delivered without tests. Yet in the analytics world, it's rare that people do a lot of automated testing. There's a lot of manual testing, a lot of, it works. And that comes down to hope. A lot of people hope things work. And hope is not your friend. And so if you live in an analytics world and a team where everyone's hoping things work, I don't know, it's not worth it to me anymore. And so you need to think about how you test. And you're testing 2 discrete things. One is you're testing the flow of data and artifacts as they go through. In some ways, that's maybe a better term is monitoring that. And in that case, just like Toyota wanted to find problems in their production line as early as possible, you want to find problems in your data as early as possible. You don't want a data error to show up on some model or dashboard given to your business customer or the end customer. Likewise, since our view of the world is all these tools produce code, you have to test that code to find out if someone broke it along the way. How do you know that that code is still working? And so we believe that a fundamental perspective on what you should do is test the data as it flows through your system and test each individual piece of code so you know that it works day in and day out. And then finally save the test results because they're actually good data for you to use. And so, like I said, there's kind of 2 benefits to testing this. One is to be able to do quality monitoring over the production run. We have some customers who are interested in producing a quality dashboard for their data. And then fast development. Actually, if you can prove that things work, you can make changes quickly. So the second step, a version control system. So when I use the term version control, who here knows what that means? Okay, that's awesome. Probably about 70% of you said yes, so 30% who don't. What version control means, it's kind of like a Word document and track changes, where the track changes work for lots of people editing the same document. And so it's a way to keep track of changes in a text file over time. And so our perspective is that all the work that you do in data science and visualization and data engineering is code, and that code should be kept somewhere. Specifically, it should be kept in a version control repository, open source Git, there's other open source tools. Don't keep it in your file system. And I find it interesting that you read all these books about, oh, we're a data-driven organization, we're trying to get data and be competitive. And yet, those corporations, if you're trying to be data-driven, trying to be competitive, the core intellectual property you're creating is that code. And so you should be able to keep track of it, version it, back it up. Branch and merge. So this is a diagram. If you walk into a software developer's office, or a software manager's office, you'll often see these kind of forking diagrams going back. And what it means is if I've got all my code, my workbooks, my R model, et cetera, in a version control system, people are working on the projects at the same time. And in this one, there's two sets of people working on task A and task B. And that line that goes across the middle of this diagram is kind of the trunk or what's in production. And people are taking a copy of it and working on it. And then when they're done, they have their changes that they're adding back in to production. And so that's a branch and a merge. And at the end effect of what that does is it allows people to work on the same set of tasks simultaneously, but not step on each other. And again, that's supported by Git or other version control systems. And the fourth is use multiple environments. So what that means is, again, going back to my software development days, I would never dream of having a software development team where they didn't have their own dev box. I wouldn't think of having 5 people work on production at the same time. And so what we believe a fundamental part of the velocity of a team is that you need to be able to create your own environment to do your work. And what's in that environment? Well, first of all, maybe all the data or some of the data that you're working on, the code that actually doing the processing. In some cases, the hardware that's your own. You want to have your own world where you can make changes and not break anything. And that gives a feeling of safety, because after all, data ops is after this feeling, a fearless feeling that you can make changes and put them in production and not break things. And fear is actually a real challenge I see for analytic teams. And so if you can't, and the only way I see to do it is give people their own environment, have a whole bunch of tests that prove that what they've done hasn't broken anything, and then add some more tests on what they've done new. And this also works for teams, not just my environment, but other teams. So you should have multiple environments. One environment's production, maybe another environment is my own development environment. Some companies have stages where it goes from development to QA to test. But the idea is that you need a controlled environment to do the work. And in fact, you kind of need sort of version control on your environment, which leads to my next one. You don't want to have a library of an R library in your dev box that's different than the R library in production. And so that goes to this next one, reuse and containerize. Since analytics is now in the complexity business, right? You don't want to have to rewrite code. You want to think about how you modularize, how you refactor, how you reuse code. That should be part of your daily diet. And then second, there's a technology that's come along in the last 3 years called Docker, which is a way to contain environments. It's a way to kind of version all the software and hardware files you use to run something. And there's different ways to do this. There's Amazon machine instances, there's using Docker, there's just using scripts. But the main idea is I want to reproduce, if I'm going to make a change, I want to make sure that I don't break what's in production. So in development, I should have the exact copy in terms of versions and libraries, et cetera. And so practice environment version control. 6, parameterize your processing. And so, as an example, working with Modin, there's cases where he has a sort of a daily or a weekly data feed, and that data drips in over parts of the data. There's, 20, 30, 40 data sources, I don't know. They drip in over a week. And we run parts of his work on Monday, parts of it on Tuesday, parts of it on Wednesday, for the sole purpose of finding out if the data's bad. And so that way we have one process, but we've parameterized it. Likewise, we've also run multiple versions of the same process. So in the case where Modin would want to change, we'll give him a version of a database that he can run and see just himself, while the 100 or so people who use the other database are on production. So if you parameterize your process, treat this end-to-end process as a function that you can run. I can run it here, I can run it there, I can split it up. It enables you to achieve some velocity and flexibility that create, again, a safe working environment for you to do. And the last bit I'm going to talk about before we ask you to do an exercise is orchestrating two journeys. So I think there's one journey that you do, which is really that journey from data to value. And lots of companies have lots of data sources. They have lots of ways to transform that data, integrate it, put it out. But at the end of the day, that's kind of, in some ways, what we do day in and day out. And think about the tool chain that you use, whether you use R or Python or ETL tools. Try to automate that tool chain. Try to measure it and monitor it. And think about the operational ease and velocity at which you can fire these things up and run them. Because we've talked to people where just trying to make a 4-line SQL change and a 1 change line to graph takes months. And so why is that? Why should it take months? Helping to orchestrate your journey from data to value is an important part of making you able to go fast. And then finally, orchestrate a different journey, the journey of your ideas to getting it in production and then refactoring it. So another way, Gil brought up this idea that analytics decays in value. And so that you're only good as your last report, you're only good as your last model, you're only good as your last dashboard. And I think that's sort of true, because really you're in the business of creating ideas. And that's why analytics is cool. You can kind of create value out of vapor. But you got to get that idea out of your head into development and into production as fast as possible. But also you got to be able to take that idea and reuse it, refactor it, reprove it. And so this cycle of idea to production, idea to value, try to time it, improve it. That's actually a key driver of your success. And to do that, you have to work on automation, deployment automation, and think of trying to measure that cycle time. And finally, you kind of have to do these two things at the same time. You have to worry about how to improve your development cycle, but also your development journey, but also how data goes from source to value. And that's what makes this data ops a little hard, because we're doing sort of both at the same time. And why we kind of see the intellectual heritage coming from left or right, data to value is kind of the industrial process control. That circle from idea to development is kind of the DevOps idea. And overall is kind of working in an agile process. So the 7 steps in action. So if you, in agile, you start with a story, which is kind of a requirement. The way that we work, and we've worked with Modern, is we create a branch in an environment at the same time. A branch is a hunk of code and an environment to do your work. We implement a feature. We write a bunch of tests for that feature. We run the new and existing tests. We compare it with historic test values. Everything's great. We check in the code. We merge to parent. We delete that environment and then update production. And so when the sprint ends, we kind of deliver all the completed features to the customer. We merge that sprint back to the master. And then if there's any features that are in that sprint that aren't part of that weekly deliverable, we roll them into the following week. And so that's it in terms of the 7 steps. So I guess I'm going to ask you guys for the next 4 minutes to say hello to your neighbor and answer this question. Do you use any of these 7 steps? If not, which one of these 7 steps would you implement first? Like Gil said, if you find value in this, which one would you do first? What would you do on Monday? So we'll set up a timer for 4 minutes. Say hello to your neighbor and get going. I'm not. This is what I used to do before. Okay, everybody. You know, I was worried that you weren't going to talk to each other. And so I can see that worry was not founded. So who wants to step up to the microphone and answer the question, which of the 7 steps do you do and which of the ones do you want to do? And because they're recording, if you could just stand up and... Okay, how about this? Don't walk to the microphone, just stand up and I'll repeat the question. Come on, someone...
What's the question?
Well... how many of the 7 steps do you use, and which ones would you implement first? Awesome.
Yeah, just to get it started, we had a good discussion, and I think we both tend to use most of the steps. On our side, we don't really containerize. We don't have a Docker. So people have to kind of rebuild their own sort of environments from what other people have done. And then I think you were saying that because of the revision control system you have, that you don't do the merge.
Or we don't do the branching.
Branching. Okay. Yeah, so that's some input.
So I'm too late.
Okay. Hopefully I spoke loud enough.
Okay, so next person gets the microphone. So, hey, Gil up front.
Hi, my name is Arda of Deutsche Bahn in Germany, a major railway company. I've talked to Deepak. I didn't understand the company name, but...
It's Kayuga Networks. Kayuga Networks is a cybersecurity startup.
Oh, yeah, that's right. And, sorry, they do pretty much everything. We do most of the things. And the thing that I would do first is just to have a clear understanding of how your data leads to business value, even before those 7 steps. Sorry.
That's fine. That's good.
Hey, my name's Tyrone Jones. Our company probably do 1.5 to 2 of them, maybe. A lot of them prove difficult. Probably the biggest one you wanted, from my perspective, is have multiple environments. So I'm a developer, so that would definitely help. The pushback from the organization is more on control and compliance. So they're very worried about data being everywhere. So the solution was everyone just work on this single area that we can control. So it's good for control, but environment-wise, it makes it pretty crazy because everyone's in there, and you don't know if your stuff will disappear when the person after you comes. So that's it.
It's a great comment. There's often a tension between groups moving quickly and having autonomy, and then wanting to maintain central consistency. And they both have advantages, and there's tension between the two. So, for sure.
Else? There's a lot of talking. You guys weren't answering the question? What were you talking about? Lunch? There's somebody in the Gil, someone in the back. Wait.
There you go.
One thing I've noticed about data science projects is that the results are often non-deterministic, whereas software is often deterministic. You feed the function this thing, and it brings out this other thing. But with an analytics project, that might not be the case. And testing, or especially unit testing, a non-deterministic thing is hard. So I think that one hard thing that I've found on my team is the first one, adding logic tests to things that are specifically like the code that runs a model or something. So, but it would go very far toward increasing that sense of safety and speed in deploying new things.
Great. Okay, thank you.
Somebody else? Come on, one more. Just bring up what you had for lunch. How about that? Anyone else?
Hi, my name's Henry. I'm from CareDocs. We will work with emergency medical emergency medical records. And I would say that we do maybe 5 of the 7. I think what's hard, and we're talking about data, of course, right, not code. Right. So number 3, which is branch and merge. Obviously, when you get a huge amount of records, you can't just branch and then merge it back in. So I think that would be a very hard one to accomplish, in my personal opinion. And I'm not sure I understand number 7 very well, but I'm pretty sure that we don't do it.
Great. Any other? One more? Please? No? Okay. Okay. You can add one.
All right.
Yeah, the thing that was new for me was really the thought of having of testing your data and not just the software. It's kind of implicit because your software manipulates data, but the idea to think about your data model and figure out, okay, how's the data coming in and how is it supposed to look like when it comes out of your pipeline step or whatever, that's something I have not thought about it carefully enough, and I want to thank you for pointing that out in your talk.
It's great. Yeah, it's definitely an art to testing data. And just to comment, it could go from very simple, like just checking row counts of a file and comparing it to history, and does it break trend? And that's so simple, but I've seen that save people's so many times. Or it could be very sophisticated, looking at comparing values at a deep level, group by segments, and comparing that period to period over time. But something is better for nothing. Our advice is if you have a data process, like put one test on every major step, and you'll be so much better off than having no tests. Oh, we got one more here. Yeah, another one. Here you go.
It's a basic question about the logic test. Like what we are actually looking at in this stage, like logic test. What does it mean?
What does a logic test mean? So let's say, in the case of, let's say you have a predictive model that is supposed to bucket in 5 buckets. So do a test to make sure there's 5 buckets and not 6 buckets, or that the buckets are named the same from time to time, or that the relative counts in each bucket stay constant over time. And so in them, you're testing the data, but you're actually testing that someone hasn't changed the logic and suddenly they've decided to make 10 buckets. And so the point of it is that you have 2 actions that are going on in your world. One is you've got people making changes to code that you've got to prove that it works. And then the second is you've got data passing through that you want to prove isn't going to be wrong and embarrass you. And so think about those 2 things in your testing. And so I wish we had an automatic bullet that tested everything, but it's not. It's part of the work that you have to do and handling the complexity of it. You can't test everything. And so you have to find what's the right point and what the right level is to test. And there was a question around versioning of data before, and how do you version data? And there are some companies who do data versioning. I think there's a company called Pachyderm that has a new product. The way we think about it is that storage is cheap. And if you just address different data sets with different parameters, like it's this month's data versus last month's data, you don't need to actually version the data. You just need to be able to address it and parameterize it to be able to get consistent results. Yeah, and so thank you, and we're going to move on to the next section.
Okay, so now I will go over how we've been doing this with Data Kitchen's help at Celgene. So from my own perspective, let me first give you a bit of background on the pharmaceutical kind of situation and the industry I work in, and that kind of level sets why we think that this data ops process has been so valuable to what we do. In general, as you may or may not know, a pharmaceutical drug nowadays can take $2 to $3 billion to bring to market. So by the time we're ready to do that, it's really important that we maximize every aspect of our commercial model And one of those aspects is, of course, what the analytics team does in supporting our various stakeholders. We have a goal of trying to essentially get to our peak market share as quickly as possible, because when a drug comes to market, it's already halfway through its patent life, and we need to try to maximize the revenue we can get in the limited amount of time that's left. And one of the ways that we do that is by mining our data to see how we can increase adoption to what will eventually be the maximum market share for that product. So on our analytics team at Celgene, we have quite a few data sources coming in all the time. We have both data that we purchase. The major sources we purchase from are called Symphony Health Solutions and Quintiles IMS. If you've worked in the industry, those are relatively common names, and we're able to purchase data like what a physician might be prescribing of a given basket of products, or at an anonymous level, what are patient level data to understand better the story of what patients have, how patients experience a disease. We also have a lot of internally produced data, usually coming from our sales force, which uses a product called Viva that sits on top of Salesforce.com and generates a lot of data about their activities that we then merge with other data that we have. And then we have more general data such as census data, or even what media markets there are in the country, which we call DMAs, that we then also layer on to our database. All these sources, with Data Kitchen's help, we have put into one database that we have ready to use for our analytics purposes. And so then using that data, we have various stakeholders in the company that we're constantly producing for. This can range from doing standardized reports that basically go out weekly, to doing a lot of ad hoc analysis, because once people see the reports, there's always new questions, especially in any given week there could be changes in the marketplace that obviously generate new questions that we need to answer. And then finally, we also sometimes do more advanced work with the data. And in this case, and this I'll get to a bit later, what's really nice about what we've created with Data Kitchen's help is that when we do advanced predictive analytics or other types of statistical analyses, that usually isn't done by us internally, but we're nonetheless set up to quickly bring up to speed any consultant or other partner that we bring on board, and simply turn on the data to them so that they can work with it and help us answer the questions that we have. So you might say, what's our as an analytics team, what's our overall goal? And it's basically to allow fast changes to support investigative analytics and high-quality production deliverables. So I'll kind of now break this down into kind of how our team looks and how it operates, and how we're ultimately able to deliver for our customers. And also then I'll go over a few examples of what we've done in the past 3 years that I've been working with Data Kitchen, to give you a sense of how the way we've set up our data and the tools we've chosen to use have really helped us deliver quickly for our customers with a high level of quality. And also, as I go, if there are any questions, do raise your hand. I'm happy to pause. We've kind of laid this out in terms of what we think would be interesting, but I've been immersed in this for 3 years, so your questions can certainly help me make sure that I'm kind of filling in any of the blanks along the way. So first, in terms of how our team is structured, we think of our team not only as the people working at Celgene, but really including Data Kitchen on one end as our data engineering team. And also we have, as I mentioned, data scientists that are usually our consulting partners. And I would describe myself on this spectrum as the data analyst. And on the far end of the slide is, of course, our customers, which in a pharmaceutical company is basically the sales and marketing team, as well as the payer marketing team, which is who deals with the insurance companies. Each of these people on the team have their own distinct roles, but we also have, also sitting with Data Kitchen, but helping across the team is what we call the Data Ops Engineer. And the Data Ops Engineer enables everyone along this process to deliver for their customers. So the Data Ops Engineer orchestrates production and helps monitor quality. They get new work into production, and they help us use the tools that we love and want to use. What this enables for us to do is that everyone involved in this process adopts something of what we call a superpower mindset. So what this kind of is getting at is the idea that everyone in this process is focused on their customer. So the data engineer is focused on delivering for the data analyst and the data scientist. And us sitting at Celgene are focused on delivering for our various stakeholders in the company. And what's really critically important about the infrastructure we've built to do this, something my boss often talks about is how we are basically firemen, because so much of what we do involves business questions that are fire drills. Executives want an answer quickly, and we need to find a way to get them answers as quickly as possible. The infrastructure that we've set up with our data allows me to either dive into the database as is and quickly start doing ad hoc analyses, or in the more advanced cases, I will go back to the data engineer and ask for his help in basically either creating a new version of the data or somehow mixing and matching data in new ways so that we can start experimenting with it and try to get at whatever question we're trying to answer in the moment. In terms of timing, the way we work, and the cadence with which we work, in terms of working with Data Kitchen as the data engineering team, we have weekly check-ins with them where we go over a prioritized list of what needs to be worked on. And in terms of what we do at Celgene, the data analyst team meets daily to do something similar where we're prioritizing and constantly making sure that we're addressing our customers' highest priority questions first and basically repeat. To help facilitate this, there are a couple of process tools that we use that not only helps us organize our work, but also helps keep everyone on the same page in terms of what's going on at any given moment. So the tool that we use across both Data Kitchen and us at Celgene is a tool called Confluence that we use for a wiki. So basically on this wiki, we document any key procedures or other things that we need to note, not only for ourselves, but whenever we're onboarding new people and want to quickly give them a reference so that they can be caught up with what's available, whether in terms of our data or in terms of the processes we use. We can basically refer them to the wiki. And then we also use Jira as a way to, this is a tool we use basically to track our work. I think of it as basically a team to-do list, but Data Kitchen, even though we're using the same software, Data Kitchen has one Jira board for itself, and we at Celgene have another Jira board. And in both cases, we're able to use that as a way to not only coordinate work across the team, but constantly prioritize our work so that we know we're getting to what our customers need most immediately. So in terms of technical tools, as Chris was saying earlier, this is about us being able to use the tools we choose to use. And because of the DataOps platform that Data Kitchen has provided us with, at Celgene, we've chosen to use two tools in particular, Tableau and Alteryx, that allow us to connect to the the database that sits on Amazon Redshift and lets us do what we need to do with the data. But at the same time, whenever we say turn on the data to one of our consulting partners and they need to start working with the data, they can choose really whatever tool they want and similarly start working with the data. Yeah, please.
Is there a reason why the 7 steps are laid in that order?
That's a great question. Is there a reason why the 7 steps are laid in this order?
No. The trick with the 7 steps is to actually do all 7 at the same time. They kind of interplay and feed off each other. And then, depending, like in an agile way, situations are different. So some organizations will benefit from one step more than the other. So they're not really in any particular order. Although one of my favorites is data testing because it lets you relax on the weekends. Yep. What platform are the data scientists using?
Great question. So, great question in part because it varies by who we're asking. So, for instance, one of our primary consulting partners, they use SAS. No one on our team at Celgene uses SAS, but it doesn't matter because whether you use SAS or Alteryx, you can easily connect to Redshift. So, right. So the question is about who is playing the different roles that we have laid out here. Great question in part because, and this is how I need to fill in the blanks sometimes, I'm describing it from the perspective of how Celgene has been doing this, but certainly you could potentially have all these roles within one company, or you could break it out the way we've done it. So specific to our example, yes, Data Kitchen has been our data engineering portion of the team. Who we have sitting at Celgene is primarily the data analyst portion, and then the data scientist is usually a consulting partner, in part because the questions could be so varied, and we don't have the skills internally for that, nor do we expect to hire for that, because you never know what the next question is going to be and whether or not the person you hired is the right person to answer that question. Mm-hmm.
Oh. Yes, you could use it internally. We're happy to talk to you. We have a booth. We're happy to talk to you more. But I think the key thing here, it's all about control, right? So with the data engineering, the data analyst, the data scientist, that's under the control of one group. And I think where companies run into trouble is when the data engineers are like in another group and are not responsive. So it doesn't matter like who it says on the employee ID badge. It's that superpower mindset that the data engineer is working very closely with the data analyst, and the requests from the data analyst don't end up on some queue that's serviced in 3 months.
What's the output of the data scientists, the consulting partners that you have? Are those reports or maybe just questions?
Right. So that the data scientist role for us will generally be ad hoc projects. This can be, it's quite varied because it's the ad hoc questions. So for instance, last year we had one of our partners develop a statistical model to try to predict who would be the next wave of new prescribers for our product. And so in that case, we gave him access to what sits in our database is the prescribing history of physicians around the country for about the past 4 years. And so they tapped into that data and pulled what they needed to start building their statistical model. Another thing we recently did with yet a different consulting partner was for them to optimize, based on a set of business rules, optimize who our sales force should be calling on. So kind of evaluation project to determine tiers of our prescribers with the most potential value to us. So to give two examples, but it's innumerable. That's the beauty of the process is that we can kind of point the data to whoever we need to that can answer the questions.
Not really web services for real-time scoring. Like the Azure machine learning platforms.
Yeah, really the way they work is they access the consultants come in, access the data, use whatever tool they want to do, and at the end of the day, they deliver a file. And so it's kind of a black box. And pharma is like this because there's so much value to be had in a short amount of time that paying kind of higher-end consultants who have specialized skill, who've seen patterns across different organizations is worthwhile. So you're buying their expertise not only in the domain, but also in data science.
Right. Most of the consultants we work with are deep into the pharmaceutical space. And then, yeah, because we work with different vendors, usually what determines who we go to is based on what we know to be their expertise, even within pharma. And since that is so varied, is why we don't even attempt to have those people in-house. So I'm going to go through a few examples of what we've encountered over the years that are instances where the way we've been set up has helped us to efficiently accomplish the end goal. But as I go through these examples, again, feel free to ask questions because maybe you have something else in mind, and I have many more examples than just what I'm going to walk through. So first example is an instance where there was basically a new business question that required an entirely new and rather large data set to be put together. In essence, what was going on with this instance was in pharma, we are able to also not only get data from a large vendor like Symphony or IMS that I mentioned earlier, but we can also go to various pharmacies directly and start buying data from them. And this is an instance where we started to do that. But when you have a bunch of different pharmacies sending data to you, as you might imagine, it's hard to get them all to agree on delivering it in the exact format that we need it to be in. So what happened was basically at the start, we had them start to deliver the data, and we created what we call a scrappy star. And this is basically the first attempt to put the various pieces of the data together. And then we started to have a back and forth. So we send questions to the suppliers of the data, and all the while keeping both the Data Kitchen team and the team at Celgene kind of in the loop. We get answers to those questions, and Data Kitchen would add various data tests and try to ensure the quality of the data as we had a greater understanding of what was being delivered. And then once an iteration of that is done, they would share the star with us at Celgene. We would try to work with the data and see if it was delivering what we need. And then we would provide feedback to Data Kitchen, and the process would somewhat repeat. Along the way of doing this is actually what's also here on the next slide, which is, in essence, the way in which we at Celgene were trying to use the data was by building what we call a scrappy dashboard. So ultimately, this data was meant to be delivered to end users. And in building these initial dashboards, in essence, what I'm describing here is just an iterative process of going back and forth, working with the data, and trying to improve it until we could make it into a high-quality dashboard with data that we could really trust, that was being delivered to our final customers. And so at any given point in the process, what we're publishing to our end customers, we think of as maybe 70% done, because over time, we've continued to improve upon the data that we're receiving from our pharmacy partners and working with Data Kitchen to put in additional quality checks and additional business rules so that ultimately the data that flows into our dashboards is efficiently answering the questions that our final customers at Celgene are looking for. In this particular case, this data is being used primarily by our payer marketing team. So these are the people that go out and work with various insurance plans. Yep.
Yeah, so I think we've also seen like different companies get stuck. There's a new data set, and there's this desire to be perfect right away. And with that agile mindset, what we find is successful is get something out there, right? Get it working from data warehouse to model or to dashboard. Get that going as quickly as possible, because just by making it visible, just by using it, you discover a lot and then improve. So why do we call it scrappy? Because it's fast, like a fighter, but it also has the word crappy in it, which conveys a level of quality. And that's kind of an agile technique that we use.
Any questions about that? So another simpler and actually relatively common example of what we've had to do is where there's a business question that requires a new Excel file. The thing about that Excel file is that we need to blend it in with the rest of the database. And that doesn't always, that could potentially be difficult, but because we're able to use a tool of our choice, Alteryx, we're able to quickly tap into not only the database sitting on Redshift, but also have Alteryx pull in the data from the Excel file, combine the two, and publish the end result on Tableau online. And so this is something that we do all the time and works relatively, actually not relatively, it works very smoothly, and is kind of the way in which we've come to work with what I think of as small data blended in with our much bigger data sitting in Redshift. I think what's nice about this, though, is we chose Alteryx, but you could choose almost any tool to do the same and achieve a similar result. Anything you wanted to add? This next example is an instance where we needed to, the fact that we test the data is a good thing. And this is an instance of both where the test would needed to be flagged and how we helped improve the test even further. So we had an instance where the number of customers dropped from about 1,000 to 900, and someone in the field noticed and was wondering what had happened. So the thing is, in the business we're in, you generally expect, customers here are basically prescribers, doctors, so you generally expect the number to go up over time, not to go down. And so when this was pointed out to us, we started digging in and learned that the root cause was in another part of the company that was feeding us data about Salesforce activity. And because there was an error in that file, there was fewer customers than there were supposed to be. And what we realized on our end was that we did have a test here to try to catch this, but the test was a static test that looked for when the total number of customers fell below 800. And in this case, it was 900. What we learned from this is that we needed to have a tighter test, and probably one based more on percentages than an absolute number, because over time, we're going to have ever more customers. In a subsequent... And in a subsequent version of this, we further refined the test to make the lower end even tighter than the upper end. The idea being that even a small drop in the number of customers is more suspicious than a potentially large increase in the number of customers.
So we've talked about data ops, and so think of 3 characteristics of the team you want. The first characteristic is you want your team not to have a lot of hope that things are going to work and not to have a lot of heroism. The second thing is you want to exist in an environment where there's sort of low fear, where you can make changes and not fear. And the third characteristic is you want to exist in an environment where you love your errors. And so this is a case where there's an error. And errors happen. Everyone here who has dealt with data has a data error, has had to do a deep dive into the data to figure out where it is. And if you're going to move fast, you're going to get some things wrong. And so one of the ways in which the team works well together is that we've been very honest about where things are wrong, or it's a data issue, it's a transformation issue, it's a visualization issue. And in fact, we have charts where we keep track of where the errors are and where they're from. And so having an environment, a social environment on your team where you love your errors, where you can make changes with low fear, and where you're trying to get people not to hope things work and have heroism on the weekend is a social characteristic of a successful data ops-driven analytic team.
And this final example is actually my favorite example. So basically, this is something we're working on even at this moment, where the database that we already had set up, we wanted to take a fairly significant portion of it. It's the portion that contains the prescriber level data in our database, and essentially create a new version of it that had a different projection methodology. So we could do this very quickly because of the setup we had, where our data supplier, Symphony Health Solutions, simply delivered data that was had the new projection methodology implemented in it, but the files were otherwise similarly structured. And so it was easy enough for Data Kitchen to accept those files and simply point a lot of existing code to the new data to have us quickly set up and running with essentially a second version of the data that we used to have. Is there anything you wanted to add about that? All right. I don't know too much about how they produced that miracle. It's just, for me, everything worked. I had 2 versions of the data, and so I just wanted to check. What was also nice about this, as I mentioned, this new data was very similarly structured. So that made it quick for Data Kitchen to get it set up for us. But what's also nice is then on our end, in terms of our tools like Alteryx and Tableau, Tableau in particular, we were able to essentially swap out the address that the Tableau files were pointing to from one part of the Redshift database to another part, and simply refresh, and everything was working. And so in terms of comparing outputs from the old version of the data to the new projected version of the data, we were able to quickly do that analysis, and really basically from the point of getting the data from Symphony to being able to start answering questions with it for our customers was only maybe the span of a week and a half. So I'm going to hand it off to Gil again soon, but are there any questions about kind of how at Celgene we're trying to implement this process and try to be efficient and agile in delivering to our customers? Huh? Sure.
So when I work in software development, we have set environments. Here's a QA, and that's where the testers go for testing. And then here's UAT for user acceptance testing. But then we didn't use AWS.
So I'll let Gil answer this as well, but from my perspective, I know that what we've been able to do, for instance, is a lot of experimenting. So within the past year, for instance, we have what we think of as different distinct data sets all within the same database. And occasionally I'll ask them to duplicate an entire portion of the database into a separate cluster that I can start playing with, mainly because we're experimenting with new ways of using the data. And then after experimenting for a period of time, we'll probably come up with new business rules that we'll then implement back in the main database. So there are really several instances, and that works very smoothly in part because it's sitting in the Amazon cloud, and it's easy enough to bring on that additional capacity.
Yeah, so like we were talking with one company that had so much data that it would take weeks to spin up an environment. So there they have like dev, QA, production. But here we have production and then we have experiment, right? So one experiment would be development for the next week. Another would be this other projection. So we just spin up environments as needed and shut them down. And and if you're within a few terabytes on Amazon, it's pretty fast. So actually, so all set?
Yep.
All right. So actually, I have a quiz. So of these, I'll give you the answer. So of the 7 steps here, what enabled this miracle to happen? Parameterize your process, right? So there was a parameter saying get the data from here or get the data from there. It was just one parameter change, a rebuild, and we're off and running with a whole new projection. All right. So in this next section, we're going to go just a little bit deeper into the technical tools. All right, so this is the rest of the Amazon part, and we're going to focus on more of the back end than the right end. So in this picture, as we read from left to right, you've heard these before. There's data all over the place. There's lots of different data sources. Our pattern is then so how do we do this? We put it into a data lake. Then that's the data in the raw format. Then we have transformations that purpose-build it from the lake for different purposes. The 2 different projection methods. We have little subsets in little corners, and that's data ready for each need. And then finally, using Alteryx, Tableau Online, even Excel, there's data. So I'm going to just kind of walk through this process and say how we use Amazon. Right, and so the picture, that's an EC2 instance. So we use EC2 to run a program that first gets data locally. We use FTP, by hook or by crook, we're going to get that data. SFTP is still incredibly common, but sometimes we'll write a custom Python program to pull it out of an online source. And then once it's local, we use something to get it into the data lake. In this case, the data lake is S3, Amazon S3, and they have a nice command line to do that. Okay, the next step is we keep all the raw data, and in order to organize it in the data lake, there's some tricks. So we use paths, and the data lake can be S3, but you could use HDFS, you could use a file system, and it's very handy to put the dates in the path or the source of the data, because then those could become parameters to other parts of the process. All right, what's the next step? The transformations. So one way, the pattern is we have all the data in the lake in S3. We put it into Redshift, and then we do transformations. And we do that, how would you do that? You have something that injects code that gives it to Redshift to run. It copies data in. This is a build, and it transforms it into the format needed by the team you're trying to superpower. And what we do is actually, since the data arrives every week, this particular use case is kill and fill. Other use cases, when there's more data, you just keep adding to the data warehouse. But what's kind of interesting with the kill and fill is you can do a build on a machine. It usually degrades the performance of the machine, and then you could just swap it at the end, which is very quick using a fixed IP address. All right, so then at the end of the build, there's data available in the database, and we use Redshift. I'll talk a little bit more about why we picked Redshift for this use case. And there's 3 types of tables in there. There's the raw data. So step 1 is it lands in the data lake. We copy it into raw files. That's available. There's the target schema, and we like to use star schemas because that maps very nicely to Tableau. And then there are these things called QA tables. So what's a QA table? So you might have a test that says, I'm getting data from a pharmacy, and all of the physicians should have an NPI number. And those NPI numbers are 10 digits. And every physician should have one. So hey, that's a great test. Are all these NPI numbers 10 digits? If not, I'm going to put that row in there as a QA table, and that could then be sent to the supplier and also be sent to the data analytics team to work on. So as part of the process, you think about not just the tests, but then what evidence or what tables you need to then improve the process as you go on. And what's interesting about Redshift is it scales up to petabytes. So why Redshift? So we see Redshift as an analytic database. They're really good for read-only queries. They're not good for online transactions. And that's namely because how they're organized. The data, instead of being organized row by row, is organized column by column. So you can imagine if you want to grab and do a sum of all sales, and it's hundreds of millions of rows, you're just grabbing one column instead of reading through every row. So that makes it very good for reads. And it has some other techniques that make it fast, column organized, but also it compresses the data and then it scales among many machines. And then on the right are just different analytic databases. We chose Redshift, which used to be ParExcel, but under there are other columnar databases that you can use. All right, and then the last slide, once it's there, organized, it's ready for people to use with their favorite tools. So that's, we're nearing the very end. To recap, we hope you learn how to make changes very quickly using the 7 steps. Work fast in your own environment, promote without breaking things. We see it important to use the tools you love. And let me just pause and see if there's any questions on any of the parts of the talks. All right, so we'll hang out if you have some others, and thank you for coming and attending our talk.